Right now we have this prototype where we can move around, collide with walls, and shoot. However, what if I told you there was an almost effortless way to add polish to this? Yes, Screenshake. How do you add it? Let's get to that. There are many ways to implement Screenshake in games. However, what it most boils down to is translating everything on the screen by a certain amount of pixels. If you want it to be fancy, you could change how much certain elements are moved to make a parallax effect, but to be simple, I'll just be translating the entire HTML canvas. Method 1. Sine and cosine. This method will be smoother than the other we'll discuss. So, we're in the code right now. Let's do this quickly. So, we have a Screenshake amount variable, a counter variable which we need to make, Screenshake counter. Now, when we fire the bullet, we're going to say Screenshake amount, I don't know, plus equals 10. We can adjust this later. Now, what we want to do is we want to go to the render function, and we basically, in order to translate everything with JavaScript, what we can do is translate at the beginning of the function, and save it, and restore it at the end. Just save it to the stack so that we don't continually translate it, so that we can untranslate it basically. And now we take the cosine of Screenshake counter, sine of Screenshake counter, and that will be our horizontal and vertical translation. Now we'll multiply this by Screenshake amount, and if we want it to be efficient, we could technically not compute cosine and sine if amount is 0, but let's not worry about that. Now what we can do is increment our timer, Screenshake counter plus equals math pi divided by 20, just some small value. And that should be good. Now, when we shoot, the game is starting to shake more and more. However, we want it to go down. So what we can do is in the update function, Screenshake counter, or Screenshake amount, divide equals 0.9. Does that make it smaller? That makes it bigger. 1.1. Yes. Look at that. Alright, let's go over to the game view. And now when we shoot, it's a nice meaty impact. That's the recoil. That's some nice extra free polish. You'll love to see it. Alright, how about the other method? Method 2. This method may appear more retro. What we'll do is we'll change the sign of the amplitude each frame and reduce it so it dissipates. It'll be very jarring, but it might look a little bit old school. So to implement this method, we'll make a Screenshake amount variable as we did for the previous method. However, we'll be using it differently and we don't need a counter this time. So every frame, the Screenshake amount will be equal to, or it will divide equal itself, negative 1.05. This will reduce every frame and flip its sign every frame, so it's going to be really shaky and cool and vivid. So, next in the render function, we need to save the context so that we don't make any permanent changes to it. Otherwise, we'll probably lose the game as it translates away from us. And we'll translate by the Screenshake amount. So, now when we fire the bullet, the Screenshake amount should equal 10. We could also plus equals 10, but whatever you prefer, whatever you think will look better. Well, what will it look like? Let's try it. So in game, those are the vibrations, and now we spam click it, it goes a little bit jaggedy, so that's why we might want to, in the code, say it's equal to 10, so that it doesn't, because it's flipping sign every frame. So, now, let's try this. Very nice. So, this is a cool, kind of retro-ish effect, and it can look pretty cool. I guess you might use this for a nuclear explosion or something huge. However, we can also reduce the effect like this. It's a little bit more subtle. It's also less organic than the other method. Remember, you can always fine-tune the amplitude and how quickly it dissipates in order to make different effects. For example, you can make a really slow sizzle or burn by changing how much you reduce the amount each frame. Or you can make a really quick, impactful one by having it dissipate very quickly, and to compensate for that, you can make it a much bigger amplitude or Screenshake amount. That's how you implement Screenshake in games. I don't know why I said it like that, but I'll see you next time. Safe coding.